Hello class, and welcome to lesson 15 through 17, where we're going to learn how to create and evaluate expressions, just like the last set of notes, but here we'll be using multiplication, division, and exponents. Now I know this seems like a lot of lessons to put into one set of notes, 15 through 17. However, the rules are essentially the same with multiplication, division, and exponents. When we're creating expressions. So we'll lump them all together and we'll do about 3 lessons worth of classwork and homework and practice problems with this one set of notes. So be very careful when you're taking these notes because it is extremely important. We will split these notes into 2 sections. Notice that there's a table down here in the second half, so try to organize your notes in such a way that you don't double dip or miss anything on your table. Here's the first half. You can go ahead and pause it. And the second half of the notes shows the bottom 2/3 of the table. As you notice here, this top line has already been written, so please don't rewrite that. It's just there to give you reference. All right, so we'll scroll back up to the top and get started. In this lesson, make sure that you refer to lessons 13 and 14, which was the previous notes, for the basic structure of creating expressions. Okay, so in those previous notes we had those 3 steps, and those 3 steps are: 1, identify the pattern, just as a quick review, and 2, understand the equation, and by equation I mean expression, and 3, substitute value for the variable, which is basically just plug in the numbers for the letters. Okay, if you need a refresher, you can go back and watch that video and check out those notes. However, we're going to jump back in to our lesson currently. So, only difference is, from the last lesson, is that sometimes the pattern will be more challenging and include multiplication, division, or exponents. So let's take a look at a few examples here. We've got our table in the middle of the page that will give us an example pattern description, so that'll give us kind of our story problem where we pick out the pattern, and then the example of what that expression will look like written as a math problem. So we'll take a look at our first one, use basic multiplication. It says every hour Melanie would post 4 Snapchat videos of her baby brother. Right? Sounds a lot like my life and my wife with our daughter. However, we see here that every hour Melanie will add 4 Snapchat videos. So this means we are multiplying by 4. Our pattern is that every hour there's 4 more. Okay, so we're multiplying by 4. And in our expression, what that would look like is the number of videos is equal to the number of hours times 4. So if we wanted to substitute some values in there to see what this would look like, we'll write down our expression. Number of videos equals 4 times the number of hours, which means if she only posted videos in 1 hour, it would look like videos equals 4 times 1 hour, which means she only did 4 videos, right? If she posted videos for 2 hours, so videos equals 4 times h, that would look like the number of videos she posted in 2 hours will be 4 times 2, so she posted 8 videos in that time. 3 would be 12, 4 would be 16, and so on and so on. So come back to our notes. That's how it would work for a multiplication expression. Let's drop down here because sometimes you don't just have multiplication expressions, but you'll have multiplication expressions combined with an addition or subtraction problem. So we'll read this one. Steve was fundraising for summer camp by selling discount cards for $10. he was given a donation of $13. Okay, so we know that there are two parts to this pattern. It's going to be $10 for every discount card, and it's going to be plus $13. So every time he sells one discount card, he gets $10. But whatever he makes in those discount cards, he's going to be adding to this original $13 donation that he got. So our expression is going to look like this. The total amount of money he earns fundraising is going to be the number of discount cards times 10 plus his donation of $13. Okay, so our expression looks like this. M equals 10 times C plus 13. Let's plug it into an example to maybe hopefully have it make a little bit more sense. We'll get rid of this expression. Our expression was total amount of money equals 10 times the number of cards plus his $13 donation. So let's say he goes out one night and he sells like 5 discount cards. It's a pretty good day. So that means the amount of money is going to equal $10 times 5 cards plus that $13 donation. So just from discount cards, he makes 5 times 10, which is $50. But he also has that $13 donation from before. So the total amount of money he makes is 50 plus 13, $63. Right? You can replace that number of cards with anything. $5 or 5 cards, 6 cards, 10 cards, 20 cards. You just replace whatever that value is for C, multiply it times 10 and add 13. Now we'll come back and look at our last example, which will be a tougher one to really comprehend, so we'll do many examples of these in class as much as possible so we can really understand the exponents, because a lot of times exponents can be the trickiest to comprehend. So our example says, every day the alien blob would split into 2 blobs. Okay, so one blob turns into 2, and each of those would grow for a day until they split into 2 more blobs. So every blob splits into 2. Every day, each blob splits into 2 more. So we drew a little picture of that here. Before we get into the expression that we wrote, let's draw another picture so it is a little bit more comprehensible. So if we start with a blob, alien blob here, okay, that's day 0. After the first day, that blob splits into 2 more blobs. Okay, after the second day, each of those blobs creates 2 more. After the third day, each of those blobs creates 2 more. So we're not just adding and we're not just multiplying, we are exponentially growing each day. Okay, so day 0, we start with 1 blob. But after the first day, it multiplies into 2 blobs. After the second day, it multiplies into, 4 blobs. Okay, after the next day, those 4 multiply into 1, 2, 3, 4, 5, 6, 7, 8. So if you notice, these numbers on the outside, 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, 4 multiplied by 2 is 8. So we are exponentially growing by 2's each time. So if you notice, the next one on the following day would be this 8 times 2, which would give us 16. The following day, we multiply that by 2, which gives us 32. So let's pop back up in here to our expression and see how we can make some sense of it. What we've drawn here is that A equals 2 to the D power, which basically means the number of alien blobs that we end up with is going to be 2 times itself however many days there were. Okay, so back in our drawing, we have oops, sorry about that, a little all over the place here. We see that on day 0 we have 1 blob. On day 1 we have 2 blobs. On day 2 we have 4 blobs. On day 3 we have 8 blobs. So this would show us that on day 1 the exponent is 0, so it'll be 2 to the 0 power, which equals 1. On day 1 our exponent will be 1, so 2 to the first power is just 2. On day 2 it'll be 2 to the second power. On day 3 it'll be 2 to the third power. On day 4, as we go on, it will be 2 to the fourth power. Then day 5, 2 to the fifth power. Day 6, 2 to the sixth power. Day 7, 2 to the seventh power, and so on, which will give us each of those consecutive days will have a new value for the total number of alien blobs. So that's all we have for the notes. I know that's a lot. We've crammed in 3 different types of expressions into one lesson. However, it does follow a similar pattern. We'll practice this over and over, and I think we'll get it pretty quickly. That's all for lessons 15 through 17. Thank you very much, and goodbye.